that. Good. All right. Oh, could you get the door? Thanks. Live? Okay, great. Are we recording? Terrific. Okay, good morning. My name is Steve Maher. I'm with Risk Management Professionals, and welcome to our continuing series on process safety and risk management issues. Basically, what we've done is this is an outreach program based on our continuing work in the field of process safety management, risk management programs, and also offshore SEMS. What I'll be doing is this will be Module 8 of our HAZOP study course. It's a continuing course designed to emulate and provide tips on best practices for the performance of hazard and operability studies. Before we get into it, today we'll be focusing on design HAZOPs and how to apply HAZOP studies during the design process. Before we get into that, just a little bit of logistics. And the broadcast mechanism that we're using is WebEx. It allows for interactive communications for all the participants. We actually use it pretty frequently for for facilitating long-distance HAZOP studies. As part of that mechanism, all those capabilities are there. However, we have to mute the participants so that as you have meetings, answer the phone, and get involved in other things, it doesn't disturb everybody's ability to tune in and get something out of. I hope get something out of this presentation. At the end of the presentation, there'll be an opportunity for question and answer. You can pose questions to our producer, Solveig Sather. Oh, what's the producer moniker? RMP Corp. Okay, it'll show up as RMP Corp on your screen. You're welcome to pose questions via a chat window. If you'd like to be taken off mute and start a discussion or ask a question directly, you'll also be welcome to do that. Also, during the presentation, if you have problems, feel free to call the number on your screen, 877-532-0806. Somebody will go ahead and work with you to try to resolve any computer problems or other issues that you might have. Also, with respect to this medium, the windows that are on your screen are sizable. If you'd like to, the one in the upper right-hand corner, which is a video of me, is something that can be resized, moved around, or whatever you want to do. The main body of it will be a PowerPoint presentation that will show up in the center of your screen. And again, at any time, if you do have problems, call that phone number or interact with our producer via the chat window. Are we good? Okay, great. All right, so what I'd like to do before we get into design HAZOPs, this is a topic that we're seeing more and more of. The nature of how we design our process facilities is changing. We're making more use of modularized components. A lot of that is driven by where the items are fabricated versus where they're designed. And because they're modularized, the projects are usually stepped up in pace to take advantage of that modularized design. So a lot of things are happening at once. Designers, fabricators, everybody's in different parts of the world. We're actually going to have another portion of our HAZOP series that deals specifically with how to control groups over long distances and using some of the modern telecommunications tools. Today we're going to focus on, okay, what do you do if you have all these different disciplines, vendors, suppliers, and everybody together? How do you control it? How do you handle it? How do you get the most out of it? Basically, what we're seeing is that the whole idea of a safety review, because of the pace of the project, kind of has to be enveloped as part of the overall design formulation and the design review process. And basically, it's kind of an interactive and stepwise activity that's got to keep pace with the design itself. So we've been doing a lot of this, and what I'd like to do is share tips from a lot of these applications and show you how you can effectively use a HAZOP study not only to address safety issues, but also keep the design process going, resolve design issues, problem solving, and decision making during the design process. And the end product will be that you've kept up with your safety issues, so you're not likely to have large-scale or expensive surprises at the end of the design phase. So my key objective is to share some insights from some of the experiences that we've had. These on the screen are the previous HAZOP modules. This fits right in because this is one of the challenges that facilitators have now. how to deal with a rapidly changing design process, fast-paced, a lot of pressure for management to get things done, and to make sure that you're maintaining the level of safety that is required. So the key things that we're going to get into today are taking a quick look at PHA techniques to make sure we're synchronized in terms of what sort of things can be done. How do you pull together design formulation and design review into the HAZOP? A little bit about risk-based decision-making with a couple of quick examples. I'm going to try to keep the whole presentation about 45 minutes or an hour. Those of you who have been part of our HAZOP series know that I can extend it a little bit. I'm going to try to keep on time and keep things focused, and allow time for questions at the end, so that if you have some specific challenges or some additional insights that you'd like to share with the rest of the group, there'll be time for that. Okay, first thing I'd like to do is just quickly recap a lot of the tools that are out there and when you use them. On the left-hand side of your screen, you'll see a lot of the simple tools that get applied a lot, as-id, what-if, checklist, those kind of techniques, very qualitative that ask basic questions. On the right-hand side of the spectrum, you'll see a lot of the more complex risk quantification techniques, such as fault tree analysis, event tree analysis, layer of protection analysis, and also bow tie techniques. I'll quickly show how all those fit together. The green area in the middle is really the workhorse of a lot of the things that go on for safety reviews. JSAs get involved a lot when you're dealing with procedural or stepwise activities. HAZOP studies is a workhorse for doing a thorough safety evaluation of a process design. And so what I want to do is not reinvent the wheel or do something radically different, but show you how you can do the things that you have to do anyhow, which usually involves a good quality HAZOP study, and transform that to accommodate this new paradigm in terms of how we're doing designs, and also how you do it effectively and get a lot out of it, get a lot of value out of there for the project. All right, well, it's no coincidence that a lot of those tools on that hazard analysis spectrum are scenario-based. Understanding a scenario, the frequency of what can happen, and how bad it is if it does happen, is paramount to understanding the overall importance of the event. Understanding importance is paramount to understanding if there are vulnerabilities in the design such that improvements need to be made. Now, during the design process, there's obviously a lot of things that operations can do to address an issue, address a plant upset when it occurs. But the designer, the challenge is to try to find those weaknesses and work them out of the design, or make sure there's enough independent protection layers to ensure that the operator doesn't have to be 100% reliable in terms of responding to plant upsets to keep it from turning into a catastrophe. That's the designer's job. The designer has to minimize the need for operations to have to address things quickly, accurately, to prevent catastrophes. So the objective is to use these HAZOP studies as a mechanism for flushing out weaknesses and addressing them. So all these techniques, you're trying to, all these scenario-based analysis techniques, you're trying to identify scenarios, the scenario ones, the low frequency, low consequence, from the scenario fives, the high frequency, high consequence, sort through them, identify where weaknesses might be, and that way you can focus any improvements in the design and your design energies on specific areas. I like this slide. A lot of people don't, but to me it kind of brings together a lot of the concepts for a lot of these different analytical techniques. What you're looking at is a basic fault tree. It's a level control valve that can fail open, and you can have a gas blow-by. Downstream, you might want to have pressure relief. If you represent it from a fault tree or graphical depiction of the scenario, you've got, in this case, a level control valve on the left failing open or opening up in some way. It could be a mechanical malfunction, a control system malfunction, whatever. On the right-hand side, if that level control valve opens up and you have the gas blow-by, what are your protection layers downstream? Well, a lot of times the operator does have time to respond, so you can look at operator response. Also, you might have pressure relief or some way to control overpressurization downstream. So the fault tree allows you to graphically depict those and also identify potential common mode failures, which in this case could be a level transmitter. Now, how this works together with all those other techniques is, if you're looking at on the left-hand side again, the level control valve failing open, Gosh, that's a clause in a HAZOP. If you're doing a LOPA, it's an initiating event. On the right-hand side, on the very top is your undesired event. Both HAZOP and LOPA call them consequences. On the right-hand side, the protection layers in HAZOP land, they're called safeguards. For a layer of protection analysis, they're called an independent protection layer. So all these different scenario-based analyses are trying to, in some way, depict the scenario, explain the scenario, and then try to flush out, are there weaknesses or not? Everyone has all of them have their different advantages. And in fact, on this slide, a fault tree is really good for graphically representing things and finding common mode failures, but it's very resource intensive. It takes a lot of work to do a good fault tree and get something out of it. The layer of protection analysis is really good. Like a fault tree, it can be used for quantification, but again, it's a little specialized. A lot of times talking about statistics and probabilistic numbers tends to make some people uneasy. So it's something that, like a fault tree, you want to apply in a very focused manner. The HAZOP, because it is semi-quantitative. You do risk rank, but you rarely assign specific probabilities to it. But still, you're trying to develop that scenario and flush things out. The HAZOP tends to be quicker. You write your causal event, your safeguards, and your consequences in a tabular form, easier to read, but again, you don't have as much quantitative information to get out of that. So this slide kind of pulls together a common platform for how all these different techniques work together, and all these different techniques have their uses. A lot of people are very familiar with the HAZOP because you can use it to get a lot of information from a team, focus their resources, and that's why we're going to be talking about a design HAZOP shortly, by the way. But there are a lot of cases where you want to do a little fault tree, or you may want to apply layer protection analysis to get some additional information or to resolve specific design issues. This just kind of gives a little bit more background on LOPA and some of the terminology. Again, when you start applying numbers, this is a subset of this overall universe of quantitative risk assessment. When you're doing LOPA, you're talking about initiating causes, likelihoods, independent protection layers, PFDs, or probability of failure on demand, and you're trying to quantify the likelihood of getting to that undesired condition and compare that either to an acceptable target frequency or an acceptable risk threshold that might be of interest. Okay, so we talked about a lot of the different techniques that are commonly used. One of the key things to realize, and I think I like this slide because it kind of emphasizes the fact that there's a lot of overlap between hazard analysis, layer protection analysis, when you do a SIL assessment, when you do a bow tie, and it's all part of that universe of quantitative risk assessment. There is overlap on purpose. You want to, in many cases, make sure that you don't have gaps when you're doing various safety assessments. So a lot of times when you're doing a LOPA, it overlaps and it's got a lot of the same information that you get from a HAZOP study. That's by design. It provides you with additional information as you drill down into it. Does that mean you do one or the other? What we typically find works most effective is doing the HAZOP study, and for specific scenarios where it's of interest, doing a LOPA right on the spot. You know, as the team is understanding the situation, understands the scenario, go ahead and use that to glean additional information and provide probabilistic information that might be useful to the designer, or it might be useful for identifying if you've acceptably met your risk criteria for the project. Okay, good. Let's move on. Now, one reason why I have a separate slide for bow tie is a little different. When a bow tie assessment can be used for analysis, basically it's one of those tools that can help you flesh out issues, but also it can help you manage all these safety programs. When you're the designer, maybe you're part of an engineering construction company, when you're in that and you're doing the design, you need to realize that when you turn this over to the client, the end user of the system, they're going to have to manage safety, have the operating procedures, if there are any changes, manage them, train their employees, make sure there's an emergency response plan, all those different safety management system elements that if you need some more information, you can go ahead and click on the link on our outreach page for our process safety management, or risk management program or SIMS overviews, but all those different things that are needed to manage it. Well, Bowtie, by pulling together the scenario, explaining it more, it provides an ability to communicate to management some of the key scenarios and things to look out for, and also help control them too. So that's how Bowtie is a little bit different, even though it's an analysis tool and it interacts with your overall process safety management, RMP, or SIMS elements to help you manage safety at the facility. So that's how a lot of those different tools fit together. The key thing when you're looking at a project is picking the right tool. Usually you start with an objectives. What are you trying to do? You're trying to optimize your design to control safety for the community, personnel, also minimize any impacts on the environment, and also in many cases address regulatory issues. Those objectives feed into what kind of tools you use, how you approach it, what your risk thresholds are as part of an overall envelope of risk assessment and management. When you identify what you're shooting for, it can help you identify what tools are needed to get to that information as quickly as possible. Do I need to do a HAZOP? Do I need to do a LOPA? What tools do I need to really understand the scenarios, look for weaknesses, and resolve potential design issues so that I can optimize the degree of safety at a facility? That doesn't mean eliminate risk. You're never going to eliminate risk, but what you want to do is make sure that you've identified, understand what weaknesses are there, and as a conscientious professional, you've met all your necessary risk targets, you've applied best practices, and have a degree of safety at the facility that properly respects and controls the safety of the personnel operating it, and of course anybody off-site. So these are the challenges of the designer, and it's the designer's covenant with the operating company that they're going to provide a design that minimizes risks and has addressed potential weaknesses. Now, I mentioned a couple times HAZOP studies as the workhorse for fleshing these out. The reason is it's a very well-recognized mechanism for taking something that's represented as a design. You're looking at a very simplified piping instrumentation diagram right now, a recognized way of representing how a system operates. And you're transforming that into, and that perspective, by the way, is the way most designers have to start their design. How do I make it work? Well, that's great, but you also need to look at it from the other side. You need to look at how can it break? What can go wrong? And that's why you're doing the HAZOP study. It's not so much that you want to go for the coffee and donuts and want to sit there and have to pour through all the design and sometimes get a little on the board side. I've been HAZOPing since 1986. I realize it can be tedious for a lot of folks. The facilitator can do their best to try to make it exciting, but it's rarely exciting. But it's necessary for coming back through and looking at things from another perspective. And applying that other perspective is really the magic for understanding if there are weaknesses by poking holes in the design before it gets built. And that's what HAZOP facilitation is all about, is how do the HAZOP tool is a mechanism for providing that different perspective. So what you're doing is you're taking an operational view of the world through a P&ID. You're applying a set of guide words. Everybody who's HAZOPed or either facilitated a HAZOP or suffered through a HAZOP is familiar with the deviation matrix. So you apply the guide words and to process parameters to go through and identify segments of the process nodes, specific causes within the node, consequences associated with that causal event if none of the safeguards work, and then those safeguards that are the barrier between the causal event and those consequences. You're doing that in a very systematic way, applying those guide words and parameters to pull together the scenario and really understand what can go wrong, how bad is it, risk rank it, and then conclude, are there weaknesses or not. And in a lot of cases, if you don't have information or you're at the borderline and the team's not sure if it's safe or not, you might selectively apply a tool like a LOPA or something else for specific scenarios where you need more information. That's typically how we approach all our studies, is we do use HAZOP or some other tool for a broad baseline of what can go wrong, and then for the areas that you're not sure or you need more information, then you drill down and get additional information, apply a LOPA or something else to get the information you need for proper decision making and design modification if necessary. So that HAZOP is transforming an operational view of the world into a what can go wrong view of the world. But with that different perspective, that's really the magic, and it's the tool you need to provide that perspective for identifying if there are design weaknesses. And not only from a safety perspective. When you're going through and identifying design weaknesses, there's a huge overlap between the kind of weaknesses that represent a potential safety impact and the kind of weaknesses that represent a potential significant operational concern. A good example is a scenario that involves overpressurizing a piece of equipment and potentially resulting in some sort of overpressure event that can injure somebody. Well, it's also damaged a lot of equipment, so you've got a big impact on operations. So there's an incredible overlap between these things that can go wrong between safety and also providing the operational envelopes and reliability that you want for those systems. So now that we understand the different tools out there and generally what they can do for you, what I want to do is take the next 20 minutes or so and talk about how to sensibly apply them during the design process. Again, the HAZOP study is a tool. Just like any other tool, you can do lots of things with it. And what I want to do is share some tips and talk about how you use it from the classic, gee, the facility's operating, let's do a HAZOP study to make sure that we don't have some problems, and oh gosh, it's a regulatory requirement to update it every 5 years, I guess we got to do it now. Take it from that perspective to, hey, here's a tool that we can use during the design to help the design process, to help fulfill our objectives of a safe and highly operational facility, and at the same time, of course, accomplish our regulatory objectives and get that done. So that's what I really want to focus on. And then at the end of that, I want to talk a little bit about how you use that for risk-based decision making. Okay, so let's, again, why do you want to incorporate this in the first place? Well, we all have, whether we're a designer or in charge of facility operations, we have a basic responsibility, professional responsibility to make the design as safe as practical. Everybody's familiar with the term ALARP, ALARP, as low as reasonably practicable, where you're trying to achieve that level that you said, okay, we're consistent with best practices, we don't have any severe weaknesses, we've made this facility to the level of safety that we want to do. This is basically our responsibility of designers and also safety professionals. So this is what we want to try to avoid. And understanding the hazards is a key way of doing that. And so that's what this is all about. And really, invoking the HAZOP during the design process is really all about making good use of resources and the information that's available to catch problems early in the design phase where you can make easy changes very cost effectively before you get too far along in the design, then becomes a bureaucratic, paperwork, and also a very expensive nightmare. So let's talk about effective utilization of resources. HAZOP studies are very resource intensive. Everybody knows that. You've got a lot of people involved in the design process, though. The end user, engineering, project management, all these resources are available to the designer. So it's a matter of, gee, these folks are involved anyhow. They're often part of the team. How do we utilize those resources and get the most out of it? And a HAZOP study is a framework for doing that. Whenever you look, in fact, we'll talk about more about resources in just a couple minutes. So basically, given the fundamental importance of the process hazard analysis to plant safety and operability, it's not so much a question of, gee, do we need to do this, or should we do this during the design process? The real question is, how can you do a design process without involving some sort of safety assessment, some sort of ability to have a different perspective on what can go wrong at that facility, so that as the designer, you can work those bugs out of the system early and inexpensively. So the real question isn't so much, should we apply PHA, but PHA or HAZOP studies, it's how can we not apply them during the design process. So the real magic is figuring out how to do it effectively and how to do it properly. So basically, how you do that, we're just going to use the term, the shortcut term, a D-HAZOP, as a shortcut for a design HAZOP, or a mechanism for pulling these ideas together and helping the designers out during the design process while you're taking care of your HAZOP study objectives. So the real key challenge is getting as much value as possible from the HAZOP implementation during the design process. So it's all about focusing energy and resources and using the HAZOP study as a decision-making and technical problem-solving tool. I'm going to say that again because this is an important concept. The HAZOP study is not just a safety exercise. It's a way to focus energies. It's a way to focus attention. It's a way to get a different perspective on that system. It is, as much as any other tool, a viable mechanism for pulling a team together, extracting. Sometimes every facilitator knows how much work you have to do sometimes to extract conclusions from a team. But extracting those conclusions and using those resources, those people at the team, for effective decision-making and technical problem-solving. So I'll go back to this slide for just a minute. Again, it's all about understanding weaknesses. To understand weaknesses, you have to understand the importance of key scenarios, and you have to do that by understanding likelihood and consequences. It's not acceptable just to say, oh, gee, something can happen. Well, gosh, is it really bad? Is it something that just causes a minor change in product specs that I can live with? It's also not enough to just say, hey, this is terrible. We can't let it happen. All right, well, you can't ever say it can't ever happen. Okay, you want to know how bad it is so you can keep the likelihood of that event at a level that reaches your design and safety objectives. So it's really by understanding the likelihood and the consequences, the likelihood and severity of the event that gives you an idea of importance, and you can deal with weaknesses. So the key thing is, when do you do it? A lot of people ask, gee, when do I do the D-HAZOP? Well, I can't give you a straight answer. Sorry. Depending on every design team is different. Every project is a little bit different. And it's critical to be looking at the progress, when information is available, and when problems need to be solved. If you don't have enough information, there's not a whole lot to talk about. So there's some basic elements of the design formulation, or at least the questions need to be formulated. Okay, if you don't, if it's not ready, or you don't have any problems to solve, and there's no information to glean, then it's not time to do it either. So it's really a combination of what information is available and what questions do I need to answer. So the best answer I can give you is that it really needs to be part of the overall design cycle. Often iterative techniques work well. If you've got a good process background and you're an experienced facilitator, usually you can get an idea of, oh, here's the information I got. What information can I get with it? And what works well 99% of the time is to take that information and start formulating your scenarios. Even early in the design process, you kind of know what subsystems are there. You know what's needed for achieving your overall design objective. Even at the infancy of the design, you can go ahead and segment these things into various process nodes. By segmenting it like that, you can look at these different areas and at least look at high-level scenarios and start building that into the HAZOP framework. So we find is very effective is starting with what we call, perhaps a bit flippantly, a HAZOP light early in the process. And then what we do is we provide that framework, and we'll talk more about organization shortly. A key need here is having something that's very organized. But take that framework and build upon it as you get more additional information. As you get additional information, periodically you may assemble a team and have an iterative process of, okay, we've got some information. Let's go ahead and focus. Let's look at the key scenarios. Are there any major outliers or things that need to be addressed at this stage of the design? So periodically, convene a team, build on the HAZOP, get some good information back to the designers on what they need to do about the design at the early stages when changes can be made. So this whole thing by its nature as just a basic, almost as the nature of the beast, it needs to be an iterative process during the design cycle. So you have a design, you do a little hazard and operability review, you remove vulnerabilities, you optimize that, you continue with your design process, And then periodically, you go ahead and get this together and update the HAZOP study, again, to get that framework for understanding hazards. Make sure you shake them out of your design, and you do it while you've got options early in the design, early in the design cycle. This kind of graphically represents what I was trying to convey here. Basically, early in the formulation stage, a lot of people are just getting basic design concepts out there. Often they start applying a HAZID or inherently safer design concepts very early at the feasibility phase of the project. But throughout that conceptual design, through the detailed design, you've got a lot of opportunity for infusing the HAZOP study, building on it, periodically updating it, so that you can get a lot of information that you can feed back to the designer. I've worked on a lot of projects like that, and if you're careful about using the resources properly, it can be very efficient. In fact, right now I'm working on a project that I'm actually doing long distance using an interactive technique where we're doing 2 simultaneous WebEx sessions and having the PNIDs displayed on one and having our PHA Pro Notes displayed on another. And we're periodically getting together, usually about 2 or 3 times a week, just for a couple of hours to bring things up to date, to answer questions, to make sure all the different stakeholders for the design come to the conclusions and we get problems worked out. Again, back to that one slide, technical decision-making and technical problem solving is what it's all about, and that's what the designer needs. The designer doesn't need to wait until everything's polished off and the design's done for people to identify safety problems. They need to know about it early in the design process. So this D-HAZOP, or the design HAZOP, has a very wide range during the design of when it can be useful to solve problems. It can be very high value all the way from conceptual design to detailed design. Once you start getting into construction and commissioning and also operation, the value back in the design process is lowered. And what do I mean by value? Well, as the design matures, you have less opportunity to make changes because they get even the simple things can get very expensive. So let's talk about the HAZOP study as a team exercise to see how this can fit into the design process. It's really all about resources and effective utilization. The overall design formulation and design, the classic design formulation and design review activities involve somebody who's kind of leading the team. It usually involves a team. It involves representatives from process engineering, control and protection systems engineering, health and safety, and also operations. Well, when you're doing a HAZOP study, you basically still need all those same representatives, the same disciplines, but you're also maybe bringing in package vendor representatives, rotating equipment specialists, and possibly other specialists. So there's more overlap than not when you're doing a design review. So why not go ahead and roll into that, getting some of your basic safety issues identified, resolved, and documented, and using the HAZOP as a tool for doing this. It is meant to be, by nature, something that works hand in hand and 2 things that can be done in parallel. In fact, what we've found is a lot of times design reviews and design formulation go very well with the same kind of facilitation skills that you do during a HAZOP study. So more and more we find that integration of all these design reviews, HAZOP studies, all those things come together very well. In fact, the HAZOP also provides a framework for documenting action items and usually for tracking and following through on things too. So again, extreme overlap. So if there's so much overlap, why not run these things in parallel? Why not make good use of your resources? Why reinvent the wheel, or why do it twice? Really having these things run hand in hand makes a lot of sense. What we found is by focusing the HAZOP as a technical problem solving and decision-making exercise, basically you get a lot more useful input into the design. Things become clearer when you lay them out on the screen, develop scenarios for them, so people really have an ability to, like, okay, I know exactly what somebody's talking about. It's in black and white. A lot of the good techniques that we talked about during earlier modules in our HAZOP facilitation series, things like prolific use of tag numbers means it's on the screen, it's specific, and you're not guessing what the other person is talking about. So this helps resolve design issues. Again, by using these kind of exercises, you avoid last-minute complications. People who participate get a feeling like, gee, I'm accomplishing a lot here. People aren't wasting my time. I'm not just sitting through another boring meeting. They get a better feeling that they're actively contributing to facility safety. And again, it's supportive whenever you're getting more out of something and realizing, like I mentioned earlier, that the new design paradigm for the world now is moving these projects very quickly. The process economics, the ability to recognize a business opportunity where an owner-operator says, I want that facility now. I've got an ability to make money. Let's get this thing operating. Well, there's a lot of pressure to move projects fast. And by this whole concept of modularizing things and getting a lot of different organizations from around the world to contribute to things, it's great, but that means that design pace is very, very fast-paced. And it also means you got to be very careful and have a mechanism to pull all these ideas together so you're not addressing problems after it's been fabricated or after it's been installed. So using a platform like a HAZOP to resolve critical issues is supportive of schedule, keeping the budget under control, and overall project management and engineering objectives. So let's talk about typical challenges that can occur when you're applying these techniques. General challenges faced by a facilitator. I mentioned that the level of detail is dependent on the information available and the problems that you need to solve. Well, a lot of times, of course, during the design process, the information is being developed. So you've got to be very sensitive to what's available, how complete it is, and how well thought out it is. A lot of times, you can get a PNID that looks beautiful, but if one person did it and they really didn't have an overall perspective of the project, or if the design hadn't been properly vetted, it may not be very useful. It may be only worth a few minutes reviewing with a team. So it's a matter of maturity, how accurate the information is, and how much it might be changing, and you've got to gauge how much time you want to spend in that area. But that's okay. Doing a large HAZOP study is like a large mosaic. You might do a little piece at a time, a lot of detail in one area, a lot of detail in another area, and then just a general framework that you gradually build on and add more detail to. You've also got to be sensitive, and other challenges can be the availability of very busy individuals that may be in different geographical locations. The more globalized we get, the more you're using fabricators in other parts of the world, designers in other parts of the world, trying to pull all this together. There are logistical challenges. And the good news is this overall framework of this D-HAZOP, or keeping pace with the design, is a way to keep this under control and really help the project maintain pace so that you're not having a piece of junk that's sent out to the field where nothing works together, and certainly it doesn't work safely. So again, there's a lot of pressure to move these designs fast. You want to avoid changes in the associated project impacts. What does that mean? If there are problems, you want to get them identified early. And like I mentioned before, we'll be doing a lot more discussion on how to effectively, and again, you can make a mess out of this too, but how to effectively manage the HAZOP process over long distances and with many different parties using a lot of the technologies that are becoming more and more readily available. So let's talk about some other challenges and tips. You need to focus on what are the critical design issues and making sure you prioritize addressing those in terms of the depth that you develop the HAZOP study for. When the design's all done, you make sure it's complete. But during the design process, it's okay to do a little bit of the HAZOP at a time and eventually build a framework that has addressed the design issues as early as possible so you don't have surprises at the end and represents a complete HAZOP study. Prioritizing high-risk scenarios. One of the more fun jobs I did was several years ago when somebody was doing a hydrotreater, and they said, look, we're pulling this together. It's moving fast. Steve, just go ahead. You pick the scenarios. Just pick some representative scenarios in these different areas, and let's just address those. That was fun. I was challenging, of course, but that's the fun part of HAZOP facilitation, is I was going through and identifying the scenarios that I felt would be higher risk, most interest, focused on those, bang, 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 bang. We went through the hydrotreater, And we've prioritized on the high-risk scenarios so that if there were key outliers, they were identified early. Any key weaknesses identified early. It's all about moving the design forward, but doing it safely. Sometimes the HAZOP study team is a little uncomfortable with piecemeal approaches to this. It's up to you to show them how it fits into the overall framework and how in the long term a great quality, an even better quality HAZOP study gets done that addresses safety issues, and by doing it early and by doing it as part of the design process, it allows people to actually make changes that have a positive impact on safety, rather than wait till the end and everybody goes like, wow, that would have been a great idea, but it's too late, we can't do it, there's no budget, we've got to start this thing in a week. So again, early is better. You have an opportunity to correct problems before and during the HAZOP study. What we found to be very effective is everybody wants to go home at the end of the day and grab a beer or whatever they like to do in their personal life. All right? So if they can get things resolved on the spot, rather than get buried in paperwork or go through a long sign-off cycle to address action items, we've had a lot of success with that opportunity to resolve things on the spot. The process engineer gets really excited about it, and very simple, obvious improvements to safety, they're more than willing to just, a lot of times with the modern tools that we've got, they'll have a copy of the PNID on the screen, make the change on the spot, all the team sees it, they're happy with it, boom, the job's done. You've actually made it the change very cost effectively, moved it forward, and you can do that by using this HAZOP framework. A lot of the current technologies associated with pulling all this information together, and the carrot of, gosh, getting the job done means that I can go home on time for a change. So getting these problems corrected during the HAZOP study really has a lot of benefit. We also make a prolific use of parking lots. The general rule that I use is, okay, we got this parking lot, questions that arise. If we can get this addressed before our 3-day HAZOP study is over or whatever, boom, it's done and you don't have follow-up work. So again, a lot of carrots that can be presented to the process engineers. Talked about updating copies of the engineering drawings during the HAZOP study. And talked about earlier about LOPA. As necessary, if you're well prepared to address questions rather than have the team debating things or talking about things in a semi-quantitative framework, gosh, bring in a LOPA tool. Get things addressed. A good facilitator, and if you do this properly, the LOPA, the HAZOP, the design effort can all work together and actually get problems resolved on the spot. The last bullet I'll leave with is associated preparation. Being prepared, being organized, having that framework for the HAZOP study that really allows you to find things very easily, make sure things are specifically addressed and addressed only once, really makes a lot of sense. And that level of organization doesn't come by magic. Pre-work, being ready for the HAZOP, laying out, I like to do for major design efforts, I like to actually make sure it's noted beforehand and also identify at least the key scenarios or key causal events that I want the team to look at so we don't miss anything. And it maintains a structure that's easy to find things for me as the facilitator if I'm working with them hand in hand in the design process and iteratively find things later or when we turn over the product for them to do MOC. Again, a key tip is to match the analysis depth with the design maturity. I'll say that again, critical concept. You want to match the analysis depth to the design maturity. So as you get information or if one area is complete, that's fine. You can focus your energies there. You can either focus it on the high-risk scenarios or get into all the depth if the design is mature enough. You've got to think about, the facilitator has to have enough process background, understanding of the design process to know if something's half-baked. If something's not ready, if it's not properly vetted, you don't want to spend a lot of time on it. You want to spend just enough time to flesh out the key issues, make good use of team time, provide high value, and keep that design process moving, but moving safely. Also, this D-HAZOP concept allows a lot of opportunity to infuse insights from owner-operator personnel early in the design process where it matters. Okay, a lot of times if you get the owner-operator team involved early, infuse operations issues early in the design, You can have a lot of benefits to save time, focus design energies, make sure you're not reworking the problem later, and of course, that means it makes project management happy because it maintains progress and keeps the budget under control. The kind of insights that are available from owner-operator personnel are basically, is the equipment that's being designed consistent with operating company norms? You know, if this is something totally different to what they're trained on, that may be a safety problem. It may not be necessary. You know, the designer can go like, you know what, I can just use something they're comfortable with, and it's about the same cost. I can get the design done, and the owner-operator's happy with it, and it meets all our design and safety criteria. Equipment of accessibility issues. They can understand what they need to do in the field a lot better. What kind of tools do they normally use? Metric versus English units, all sorts of things in terms of their infrastructure of how they do their operations job and the tools they have, and how do you maintain and operate a facility. What their operations practices are, levels of training. What are they trained to do? What type of emergency warning systems do they have? If you're designing it, why design from scratch? Talk to the owner-operator, get them involved in the design process, and get their insights. You know, what are they accustomed to using? What kind of emergencies are they trained for? What kind of alarms do they like to hear? What do they find useful? How does this fit into their overall emergency response program? These are things that can probably save you, the designer, a lot of time, because you can make something that's very effective and not have to reinvent the wheel. The owner-operator may have standard designs for how they do certain types of modules. Unless you know that yours works better or is more effective, or there's some other driving force for do it, why don't you at least find out what the owner-operator normally does? Then you can make a very well-balanced decision on what the right thing to do is. Good. So I'd like to talk about a couple of other pitfalls and things to look out for. The key thing is knowing when to stop. A lot of people don't know when to stop and say, oh, you know what, we've reached the limits on what we can do here. Let's go ahead and make a list of action items, homework assignments, and a date to reconvene. All right? Rather than beat your head up against the wall, you've got to know how to make effective use of resources. You want to keep the key objectives of providing value, making sure that what you're doing is high quality in the long term, that you've done a complete job with your safety evaluation and your HAZOP documentation. If you have incomplete information, it can be very challenging to really make effective decisions and really do anything with it, and making sure that you have definitive conclusions. And also when you come through with it, management of change, how do you, structuring this, and if there are a lot of changes, how do you manage that? A key thing is if you've structured this properly, if your HAZOP is organized, if you've properly partitioned the work, starting and stopping should not be difficult. All right? If you've reached the limits of your knowledge, stop, but have it structured so you can pick it up easily later on and complete the safety evaluation, the HAZOP that provides this design framework, design formulation and evaluation framework at a later time. So again, knowing when to stop is critical. And again, keep in mind what your objectives are. You're trying to make a safer, more operable facility that meets project, budget, and scheduler objectives. That's a quintessential dilemma when you're doing a design project. Is the project management's job is to move things forward. So what you want to do is you want to have a framework for resolving design issues, getting things surfaced early, so you can support the overall project schedule and budget without compromising your design, without compromising safety. That's what we're trying to do here. So that's what this D-HAZOP is all about. It's about doing a good job from a safety and operability perspective while supporting the project. So again, from a control mechanism, the HAZOP provides a different perspective to the design. You can flush out the big issues early and get them resolved. It helps you complete efforts. I don't know how many times I've heard, oh, we're ready for HAZOP. We've got all our safety information together. And I go, okay, great. And then you get the team together and they bring in stuff that absolutely isn't ready yet. Also, a lot of times, when you look at it beforehand and you look at their stuff, hey, it's not ready, they scramble to get things ready for the HAZOP study. So by getting everybody together as a team, usually very conscientious engineers are going to realize that regardless of what they told management about how complete they are in the design, they need to get everything, all the I's dotted, T's crossed, and get their design up to snuff before these HAZOP sessions. So by scheduling the HAZOP sessions during the design process, it really forces completion of the efforts. It takes people and gets them to the table, makes them get the job done, and that really helps support project management's objectives too, and everybody's objectives for operability and safety. It helps you resolve information bottlenecks. It can help identify design deficiencies early, and also by getting everybody together and saying, look, are you ready to have your design evaluated? Basically, it kind of makes them get off their desk and go over and rattle somebody's chains and get the information they need so that they can get their design done. So it kind of neutralizes this, oh, I'm waiting for so-and-so, and then everybody's waiting for everybody else and nothing gets done. So it helps support maintaining project schedules, project budget, and this teamwork approach helps put issues in perspective and helps provide a platform, a forum for resolving design disputes and problem solving and decision making. So that's really what this is all about, this iterative approach, using the HAZOP study sensibly, and not being worried about it. They're classically because HAZOP studies are often seen almost as a punitive exercise to a lot of people, or a lot of people wasted time, or something that's done late in the design process. A lot of people are uncomfortable. They're hesitant to bring the HAZOP study and this overall concept early in the design process. Go ahead and try it. It really helps the project out, and it really helps provide for an overall safer and more operable facility when you're done. Okay, so could be doing better on time, but let me go ahead and talk to you. I'm going to shorten this risk-based decision-making concept a little bit, and we'll leave time for question and answer. Probably start QA in about 5 or 10 minutes. So think about any questions you might have. All right, so I want to talk about risk-based decision-making. This is fundamental to the design as you're trying to achieve a certain degree of operability and safety. So when you're looking at design options, you're looking at trying to balance out the risk averted versus what costs are involved in terms of design costs, capital costs for equipment, how much it costs for operations and maintenance. That's this whole concept of risk-based decision-making that you'll infuse either conceptually, qualitatively, or quantitatively into the HAZOP process. Everybody knows that as the project moves forward, you have to spend more money to avert a lesser degree of risk. So this whole idea of bringing things out early and applying these techniques is super critical. So let's talk about just a couple of examples. We're going to have a workshop later on to actually work through the numbers and the scenarios, but I just want to talk a little bit about a couple of ways that you can apply these techniques. Okay, the first one is Separator Overpressurization. This is an example from one of the projects that I worked on where you had a downstream separator, and based on the extreme pressures on the upstream or left-hand side of your screen, based on those extreme pressures, the potential for really having a large pressure pulse that could overpressurize the separator was extreme. There was no practical way to have relief valves that could do the job. A contemporary relief valve would have needed about approximately 30 relief valves to get the job done. So the design options were have these 30 PSVs and not have isolation upstream, versus which it was more contemporary. But you've got the other option was to have fewer PSVs but active mitigation up front. So you can use the HAZOP to lay out the scenario and look at the two design options, one being all large numbers of passive devices, such as PSVs, that require maintenance, may be untenable with respect to the design itself and operation, versus having an active safety feature upstream and fewer PSVs. So laying those out in a HAZOP scenario and then the selective application of LOPA can help you resolve what is the best design option from a safety and cost perspective. So as you're doing this, the designer often can't help make that decision. But if you use the HAZOP to do the job that you're going to have to do eventually anyhow, and lay out the scenarios, and then use LOPA to look at the failure probabilities associated with those different design options, you can help make decisions and provide the designer with enough information early in the design process to make it work properly. Another example is number of sensors. A lot of people like to put in voting logic. In this case, you're looking at a gas blow-by case. This is actually dovetails with our previous example, where level control valve 1 can open and overpressurize downstream. And here, if you do get a low level, you can have the opportunity to isolate and prevent that gas blow-by by closing EIV, or emergency isolation valve 2. Well, EIV-2, of course, the actuator is fed by a solenoid that might dump instrument air and is fed by level transmitters, in this case 2A, B, and C. So the idea is you got 2 out of 3 voting logic by different level sensors. Well, that's all well and good, but things like this can sometimes get out of hand. How bad are the consequences downstream? What is what is the likelihood? Excuse me. What is the likelihood of level control valve 1 opening? So pulling those together can help make decisions on how much redundancy you might want in your sensors. And I have to tell you that a lot of people tend to over-apply multiple sensors in voting logic. You really need to think about a couple of options. Let me talk about them. So this is an example of a simple fault tree that kind of looks at, okay, this EIV-2, emergency isolation valve 2, not closing, which is, of course, what you want to minimize. You want to maximize its reliability, so you want to minimize its unreliability. Okay, when you're doing that, you're looking at, there's a logic processing unit typically that's on your right. On your left is the valve itself failing to close. So another part of that is these transmitter failures. Well, when you're using 2 out of 3 voting logic, really the reason you're doing that is you're, we have a problem?
Yeah, I love the presentation.
Okay, no problem. Actually, we're almost done, so you'll go pretty close to the end. So what you'll do is you can model or identify the fact that you've really got 3 combinations of two sensors failing that compromises this 2 out of 3 voting logic. Well, that's all well and good, but gosh, why not have 4, 5, 6 sensors? Well, this concept and understanding how the reliability of individual sensors comes into the overall unreliability of this function of EIV-2 failing to isolate, that is what you're really trying to understand. There's this constant of the valve itself failing to close, or an LPU failure, which is usually much less likely. Well, once you've got your transmitter failures below the transmitter failure probability below the failure probability of your emergency isolation valve, you kind of get to a point of diminishing returns. You can only go so low when you're still dominated by this emergency isolation valve 2 failing to close, and so that's kind of when you can stop. And this transmitter reliability is dependent on manufacturer, the system configuration, how often it's maintained and calibrated, and also what environment does it have? You know, how good a transmitter is it? Is it in dirty service? Is it in clean service? So all those things need to go into your consideration of what's the contribution to transmitter failures to my overall unavailability of the function. And that's what you need to consider, these concepts, when making decisions on how much voting logic or sensor reliability you need. So again, these things can get flushed out if you understand the scenario. In this particular case, understand the consequences. How does it correlate with your risk threshold? And having this laid out as a scenario, maybe through the use of a HAZOP during the design process, selective application of LOPA can help make critical decisions that help the designer get the job done without overdoing it or without missing critical safety weaknesses. So, a couple of examples on how you might use risk-based decision making. What I'd like to do is identify our next webinar on August 2nd. One of the next thing that I'd like to address in our series is dealing with vendor packages. This is a critical issue because, as I mentioned, the nature of our design process is changing. Module 10 is going to address how do you do these things long distance, because you're going to get more and more into having to communicate these things via WebEx, via interactive telecommunications across continents, everywhere, and make it work as a HAZOP facilitator. That'll be Module 10. Module 9, this design evolution that we've got going on, means that more and more things are modularized, more and more things are fabricated across on the other side of the ocean. And how do you make sure that fits in with your overall design, that it does it safely? How do you control the vendor? How do you make sure they're getting the job done right from a design process? And evaluating safety is a critical part of making HAZOP studies and your overall design process work in the 21st century. So that's a critical thing, and that'll be our next module. And I guess what I wanted to do is open up for questions. So we'll go ahead, and you can go ahead and send a question via the chat window on your screen to our producer, Solveig Sather, who goes by the moniker RMP Corp. You can go ahead and ask to be unmuted and either start a discussion or ask a question directly, your choice.
To access the chat window, you need to go to the menu at the top of your screen where it says Viewing RMP Corp's Applications. If you click there, it'll pull, or just hover there, it'll pull down a menu that has a chat icon. You can go ahead and hit that chat icon, and it'll bring up a window where you can type in your question. Okay, Steve, I have one question. What is the one key tip that you can leave us for making D-HAZOP work?
All right, I think the key thing is, and I tried to emphasize this a couple times during the webinar, is being organized. Up front, having an understanding of the overall process so you can organize and structure the HAZOP into the nodes or sections that you need, making sure that you use prolific tag numbering, that you use a structure of identifying causes that will allow you to find things later, so you can anticipate what you're going to be doing with a HAZOP study, so that you anticipate having to jump around, address things as they come up, and meet the needs of your design team by working in one node 1 minute and then having to shift as necessary to another node, and even bounce around a little bit and make sure that you're structured so you can do that effectively. And it's all about providing value. It's all about making sure that you're making good use of resources, good use of the tools at hand to provide things for the designer. Technical qualifications of the facilitator are pretty essential. You really can't use the old style concepts of, gee, the facilitator can just come and ask questions. They really need to anticipate what the team needs and how to solve problems. And as I mentioned before, it's all about decision making and technical problem solving. I'd like people to get away from this concept of the HAZOP as only kind of a safety check. It's a tool. And like any other tool, knowing when to use it and how to use it effectively is critical. Is there anything else? All right, good. Well, anyhow, I hope everybody got something out of this. You're welcome to contact me by email or phone on the screen afterwards. And
we do have another question.
Unfortunately, for a lot of folks, I'm really happy to talk about this a lot. Yes, ma'am.
We did have one more question pop up. We used HAZOP during the design phase. What about HAZOP in commissioning and startup phase? What is its added value in this stage, and what kind of issues should fix?
Well, fair enough. It's a good question. Basically, as I showed that graph before, and so I'll ask you to try to page through that, pull that up if you can. It's about midway through the HAZOP. The one curve that was like a bell curve. So during the it's all about value again. The most value for the HAZOP study we find is early in the design process, so you can flesh out issues and help the designer. However, you notice the bell curve doesn't stop. It goes through the commissioning phase, and you don't get as much value out of it. But if you do need to address management of change issues, if you need to address safety questions, it's still a viable tool for doing that. In fact, it may be the only tool. But here you're doing more of a verification that what you have to do to make commissioning work is going to be acceptable from a safety perspective, not so much feedback to the designer. So you're doing it for a different reason, and you're doing it for a more classical reason as a safety check. Hey, you know what, something's not working, I've got to make some change during commissioning, and I can review the HAZOP, make sure that it doesn't interact with a high-risk scenario, or I can add other scenarios because I have to modify the design slightly. So yes, it can be used. If you don't have other tools to do that, it can help you with MOC or management of change during the commissioning phase. Anything else? All right, again, thanks everybody for their participation and joining us today. And we'll look forward to working with you on August 2nd for our next module on vendor packages. Thank you. And recording? Perfect.